Welcome to lesson 7.3, reflections. Our objective for today is I can draw the image of a figure under reflection over a given line. So remember, when we make a reflection, we have to have a line in which we are flipping it over, right? Because a reflection is, in essence, a flipped image. Sometimes we like to call it a mirror image, because when we think of reflection, we think of a mirror. And we have to have a line of reflection. Okay, so let's take a look at our chart here. So the type of transformation that we're talking about again today is reflection. All right, and what is a reflection? Remember, it's a flip over a line. So if we look at an example of a reflection, let's say we have this triangle here, right? And I'm going to label its vertices, or the points on the triangle, A, B, C. And then I'm going to draw this line directly down the center. This line right here is my line of reflection. So when I take this and I flip it over, it's going to be the same triangle. Might as well try their best to draw with the same lengths, right? This side is going to be the same as this one. This side is going to be the same as this one because that's what it becomes. And same thing with these two sides. Be careful. C now becomes C prime over here. B is now this point, which is B prime, and A is this point, which is A prime. Okay, we're going to talk about that more in a minute. So is size preserved? So if I take something and I just flip it over, yes, absolutely. It's still the same exact size, right? And is orientation preserved? What that means is if I were to read the vertice points on this triangle BAC, and I would do the same thing over here going in a clockwise motion, I'd have ABC, right? But here I have BAC, so no orientation is not preserved because when we count the vertices in the clockwise fashion, we see that they're not the same. All right, so go ahead and flip the page for me. All right, now the top one says it's your turn, but really it's not. It's my turn first. All right, so let's do this one together. We're going to reflect the triangle ABC over the y-axis. Okay, so that means our y-axis is our line of reflection. So I have to remember, okay, this right here, the vertical line is my line of reflection. It's that y-axis right there. So I'm going to bold that in so I know that's the one I'm looking at. All right, now let's plot these points A, B, C. So A is -2, 2. B is -4, 2. And as I do this, make sure you write A, B next to those, and then C is -4, 4. So it's going to look like this. All right, so what I'm going to do is I'm going to take that and I'm going to flip it over that y-axis, over that line, right? So I'm going to show you one way to do it with the transparency, but we're going to learn a different way as well. But I just want to show you how it actually flips, okay? So here's my transparency. Here's my triangle. I'm going to mark A, B, C. I'm also going to mark my line of reflection, okay? So then what I'm going to do is take my transparency, flip it over, right? And when you flip it, make sure that your line of reflection lines up, right? So when you do that, I can see exactly where my A prime, B prime, and C prime are going to be. So I'm going to mark those. So here I have B prime, A prime, and C prime. All right, so that's one way of doing it, is using the transparency. Another way to do it is to look and say, okay, A is 1, 2 away from the line of reflection, which means when I flip it over, A prime is going to be 1, 2 away from the line of reflection as well. All right, C is 1, 2, 3, 4 away from the line of reflection. So that means C prime is 1, 2, 3, 4 away from the line of reflection. Okay? Make sure that you label these, though, because when I take A and I flip it over, A is closest to the line, so it's still going to be closest. Right? B was next to A down here, so it's going to be next to A over here after it was flipped. Okay? So are the triangles congruent? Remember, congruent means that they're the same size and shape. Are they? Absolutely. Yes, they are congruent. Right? All right, so now let's take a look at this next one. It says your turn, but again, I think we're going to do this one together really quick. So we're going to take the same triangle, but instead of reflecting it over the y-axis, we're going to reflect it over the x-axis. Okay, so let's do that. So let's mark our points. It's the same triangle as before. So we have -2, 2 is A. We have -4, 2 is B. We have -4, 4 is C. Connect those points. Right? So now my line of reflection this time is the x-axis. That's our horizontal line here. So let's mark the x-axis. That's what we're flipping over. So instead of using the transparency, I'm just going to count. Right? I know that A is 1, 2 spaces away from the line of reflection. So A prime is 1, 2 spaces away as well. B was 1, 2 away from the line of reflection. So B prime is 1, 2 away as well. And you can think of this two ways. C is 1, 2, 3, 4 away from the line of reflection. So I can go 1, 2, 3, 4 down. Or because they're congruent, because size and shape is preserved, you could say, hey, C is 2 away from B, so I'm just going to count 2 away from B. Okay, so really quick, just to compare these two, let's write the coordinates for A prime. So A prime is now 2. It's now -2, -2. B prime is now -4, -2. And C prime is now -4, -4. So if I compare these points, right, my x coordinates stayed the same, but my y coordinates, their sign changed. They were positive, now they're negative, right? And that's what happens when we flip over the x-axis. So what I'd like you to do now is flip the page. Now we have example 2 and example 3. These ones are for you. What I would like you to do, please, is reflect these shapes over the given axis. So the first one, you're reflecting a rectangle over the x-axis. Second, parallelogram over the y-axis. When you're done, make sure you plot the points A prime, B prime, C prime, and D prime. And then tell me what those points are so that we can see how they compare to before you reflected it. Okay, so you're going to do examples 2 and 3. When you're done, please raise your hand to get them checked. All right, go. All right, welcome back. Let's flip the page. We have this next figure. It's a trapezoid. What I would like you to do here is draw the image of the trapezoid after a reflection over the y-axis and make sure to label it with its primes, okay? And then how did you determine the reflection of the shape? You're going to describe to me what did you do to create this reflection. Okay, go ahead and take a moment to do that one. Pause the video. Please raise your hand to get it checked. All right, welcome back. Let's look at example 5. So this is reflect triangle ABC over the line x equals -1. So this means that the line of reflection is not the y-axis or the x-axis. It's actually another line that we can graph ourselves. So to find the line of reflection here, we're going to find where x equals -1. And x equals -1 is right here, right? So this point has an x value of -1. Do you agree that this point also has an x value of -1? Absolutely, right? Because this is the point, -1, 1. So all of these points on this line are on the line x equals -1. So that's my line of reflection. So this line right here is my line of reflection, and that line is x equals -1. So now when I plot my points, right, I'm going to go -2, 2 is A, -4, 2 is B, and -4, 4 is C. When I take these and I reflect it, I'm going to count from this line right here. So A was 1 over, so A prime is 1 over the line of reflection. It's going to be right here. Okay? Do the same thing for B and C. Make sure you write your A prime, B prime, C prime, and tell me exactly what those points are. All right, tell me what you notice about the angles A and A prime and the line segments A, B, and A prime, B prime. Okay, so when you're done, please raise your hand to get that checked. Thank you. Bye.